Okay, on this one, we have a ladder leaning up against a house, a 20-foot ladder. The bottom of the ladder starts to slip. Oh, this person's in trouble. Slip away from the house at 0.14 feet per second. Bottom of the ladder is. How fast is the tip of the ladder along the side of the house slipping when the bottom of the ladder is 6.6 feet away from the house? Interesting little situation. Okay. So, I don't think I have enough room for me to draw very well here. So maybe I go like that and like that. So there's the ladder. And it's a 20-foot ladder. So this is 20 feet or maybe, yeah, I don't like that little picture. I'm going to make it a little bigger over here. Let me just go over here. It's a cute picture and all, but I think I need a little bit more room. Okay, so here's the ladder. It's a 20-foot ladder. Okay, and bottom line, yeah. So, okay, let's go through our steps. What do we have to do? Number one, we have to find the rate letters. So identify any rates they talk about. What do they say? The bottom of the ladder starts to slip away at feet per second. So that's definitely a rate right there. Here's a rate. What's that? So that's the bottom. That's how far. Here, let me try that again. Like a little arrow there. That is X, right? That's how far this is the bottom of the ladder right here. Bottom of the ladder. And it's slipping away from the side of the house. So that's telling us that dx dt, oops, sorry, I'm in the wrong mode there. Okay, so dx dt is positive 0.14 because it's slipping away from the house at 0.14 feet per second, meaning x is growing, right? That's increasing. Since the bottom of the ladder is slipping this way away from the house, that means x, the distance the bottom of the ladder is from the house, is growing, increasing at 0.15. Remember, when things are shrinking, that's negative, growing, that's positive. Okay. What other rates they mentioned? How fast is the tip of the ladder along the side of the house slipping? So they want us to call, you know, that right there to the top tip, call that Y. And they want to know how fast is dy dt changing. It's obviously shrinking, it's going down. That's why it's a negative answer, right? Because as the ladder slips this way, the y is going to go down. So I want to find dy dt, and that's it. That's the only rate letters they mention. Okay. So step two, you know the deal. You have to write an equation relating only those letters, right? You can use other numbers, but only those letters. So only, in this case, X and Y, right? Okay, well, that's pretty obvious, right? X squared plus Y squared is 20 squared. And the 20 is not changing. It's a fixed number. It's the length of the ladder. So we got, all right, that's pretty easy. X squared plus Y squared is 20 squared. Pythagorean A squared, B squared, C squared. All right. Step three, d dt, both sides. So let's do it. So d dt this side and d dt that side. Bring them two, we get 2x dx dt plus, bring down the 2y dy dt equals, that's just going to be 0 because the rate of change of a fixed number doesn't have a variable, doesn't vary, is just 0. All right, and we can get rid of these 2's right away. Now just divide 2 by 2, divide by 3, even 0 by 2, gone, gone. So we can clean that up a little bit. It's x dx dt plus y dy dt. 0 over 2 is just 0 still. So we get to that. All right, and step 4, plug in the numbers. So, all right, what are we looking for? What do we have? You see, we have dx dt. I'll go right there. We want dy dt. So do we have x and y? I don't know. Let me see. How are we going to find x and y? Oh, there's the 6.6 I haven't used. When the bottom of the ladder is 6.6 feet away from the house. Okay, so that means x is 6.6. And if that's the case, I can also get my hands on y, right? Because again, x squared plus y squared is 20 squared. So that's going to mean 6.6 squared plus y squared, and that's going to be 400. So then y squared will be 400 minus 6.6 squared, and then we can square root it, both sides. So y will be the square root of 400 minus 6.6 squared. So I got y, I got x. Let's do it. So x is it 6? I forgot. No, 6.6. 6.6. dx dt is right there, 0.14. Okay, plus, and then y is that square root of 400 minus 6.6 squared. And t equals 0. So, how do we solve for dy dt? Grab this whole term and bounce them to the other side. So then we bring this down, we get the square root of 400 minus 6.6 squared dy dt equals negative 6.6 and 0.14. Last step, divide by square root of 400 minus 6.6 squared, 400 minus 6.6 squared. Boom, boom. So there's dy dt. Let's go hit the buttons on the Desmos. So it's minus 6.6 times 0.14. 6.6 times 0.14 over square root of 400 minus 6.6 squared. Square root of 100 equals. There it is, negative 0.0489. Negative 0.0489. Negative 0.0489. Negative 0.0489 is, whoops, goes on the other side, doesn't it? So do it. Negative 0.0489 is dy dt. Negative 0.0489. There we go. That's how fast the ladder is slipping, the tip of the ladder slipping down the side of the house at, zero 04 or about 05 feet per second at that instant. And so there we go.